In this video, we're going to talk about how to calculate the moment about a point in a three-dimensional setting. So what we have here is a pole, and then attached to the pole are these two ropes here that are exerting a force on it. So F1 and F2. And F1 is 780 newtons, and F2 is 420 newtons. And we're asked to determine the resultant moment about point O. And we know that the resultant moment about a point is equal to the sum of moments about that point. And the sum of moments about a point is equal to the sum of R cross F. Okay, so you're taking the cross product of R and F. So R is just the distance from where the force is exerted to the origin, and then F is the force vector. Okay, so you're taking the cross product of these two vectors here. If you're uncomfortable with taking the cross product of two vectors, I've made a video, and I'll link that to this video for you to reference. And taking the cross product of two vectors, understanding how to take the cross product of two vectors is especially important for calculating moments in 3D. So let's figure out what R is. So what is this R vector? Well, we know that R is on the z-axis here. Okay, so we'll write our R vector. Okay, R is equal to, okay, it has no x-coordinate and it doesn't have a y-coordinate. It's just upwards on the z-axis. Again, it's up 6 meters. Okay, so it's going to be 0, 0, 6. And of course, this is going to be in meters. Now, what about the force vector? Well, we haven't been given the force vector. All we've been given is just the magnitude of the force, okay, for F1 and F2. But we can figure out what the force vectors are because we have the magnitude and we also have the direction in which the forces are pointing. So what we can do is we can just multiply that by the unit vector. So the unit vector, so I'll just go ahead and do that right now. So F, okay, so F1, okay, the vector F1 is equal to 780, again it's going to be in newtons, times the unit vector. So the unit vector, I'll write this here, is, what we're going to do is we're going to take the direction in which the force is pointing. So if we look over here, it doesn't have an x direction, so the first coordinate will just be 0. It won't have an I coordinate. We're going to be putting this in Cartesian vector form. It does have an x, or sorry, a y distance. Okay, so it goes along the y-axis about 2.5 meters. So we would write 2.5 j. Okay, 2.5 j. And then we know it goes down 6 meters from here. So 1, 2, 3, so 6 meters. Okay, so it'll be minus 6k. And we divide this by the magnitude of that. So it's going to be the square root of 2.5 squared, 5 squared, plus negative 6 squared. And of course, this will be in newtons. So that's going to give us 780 times 2.5 over 6.5 I. And so that's this right here, 2.5 squared plus negative 6 squared, and then the square root of that. So this is going to be j, sorry, not I, minus 6 over 6.5 k. So when we multiply that out, it's going to be newtons. When we multiply that out, we get, so that is when we multiply 780 into 2.5 over 6.5 I, we get 300 300J, and we multiply 780 times 6 divided by 6.65, and we get negative 720K. And this will be in newtons, okay? So this is the force vector for F1. How about for F2? What does F2 equal to? Well, we know that the magnitude is 420 newtons, so we'll write 420 times its unit vector. Well, we know that F2 goes 2 meters in the x direction here, okay? So it's going to be 2I, and then it goes 3 meters in the negative y direction, okay, so this way, so it's going to be minus 3j, and then just like F1 it goes down, okay, on the z-axis by 6 meters, so it'll be minus 6k. And I'm going to divide that by its magnitude, or the magnitude of the distance, which would be 2 squared minus 3, or sorry, plus negative 3 squared plus negative 6 squared. Take the square root of all of that. This is going to be newtons, of course. And then we simplify this, which would be 420 times 2 over 7I minus 3 over 7j minus 6 over 7k. And so when we multiply 420 into this term, what we get is 120I minus 180j minus 360k here. And this will be in newtons. Okay, so that's the first step done. We now have the force vector for F1 and F2. So now what we can do is we can just go ahead and take the cross product of R and F1 plus the cross product of R and F2. And so the moment about the origin point O, okay, or the resultant moment about point O, or I should put it this way, the sum of moments about point O is equal to, we'll use this color, R cross F1 plus R cross F2. And so what we get here is this. So for this term here, we get, put our I, our J, and our K. 0, 0, 6, that's R, and 0, 300, and then we have 700, or negative 720, plus we got our I, our J, and our K, and then we'll go 0, 0, 6, and then 120, negative 180, and negative 360, like so. And now we can go ahead and calculate from here. Now, there is a more efficient way of doing this. So As you can see here, there's two forces. What we can do is, instead of taking the cross product of individual forces and r, what we can do is we can take the cross product of the resultant force and r, or I should say r cross the resultant force. So what I have to do here is just add up f1 and f2, so collect the terms here, and I get a new vector, so I'll call it fr. So the resultant force Fr is equal to F1 plus F2. And then what we're doing here is just collecting these terms here. So, it'll be 200i. Okay, so we're going to add these together. So 120i. And then we're going to sum up 300 and negative 180, which is going to be negative 120, or sorry, positive 120, so plus 120j. And then we're going to sum up a negative 720k and negative 360k, and that gives us negative 1080k newtons. So when we take the cross product to get the resultant moment, we can just go r cross fr. So we would write it here like so. So we got I, j, k, 0, 0, 6. And we got 120, 120, and negative 1080. Okay, so instead of taking two cross products, now we're only just going to take one, which makes this a lot more efficient. So when we do that, we get this. So it's going to be 0 times negative 1080, is negative 1080 minus 6 times 120, and this is going to be our I term, minus, so 0 times negative 1080, 0 times negative 1080 minus 6 times 120, 6 times 120, and this is going to be our j term. And we put our plus sign. Okay, so 0 times 120 times 120 minus, is this 0 times this 120? 0 times 120, and that'll give us k. So when we go ahead and simplify, this cancels to 0, this cancels to 0, and this cancels to 0. So what we're left with is, we're left with 6 times 120, or I should say negative 6 times 120, and that'll give us negative 720i minus negative 6 times 120, which is going to be negative 720j. Simplifying further, scroll down a little bit. Okay, these two negative signs cancel out, so we're left with negative 720i. This is going to be in newtons. Negative 720i plus 720j newtons. And this is our answer. So this would be the resultant moment about our origin up here. Okay, so it'll be the resultant moment about this point here.